Hello, everyone. In Chapter 10, we focus on how to calculate what is known as simple interest. So, whether you are earning interest or paying interest, you should know how to calculate what is known as simple interest. Let's say that you borrow money from the bank and you're wondering how much has to be repaid to the bank. The amount that you must pay when the loan becomes due is known as the maturity value. So, assuming you took out a loan for, say, 6 months, the amount you would pay at the end of 6 months is called the maturity value. The amount paid would be the principal, the amount that you borrow, plus the interest that has accumulated on the loan over that 6 month time period. So the principal will be the face value amount of the loan, and the interest is what we call the cost of borrowing money. Everything has a cost. So when you add the principal plus interest, it will give you the amount of the maturity value. We have a formula for calculating simple interest. The formula is principal, the amount borrowed, times rate, as in the interest rate times time. And depending upon how much you borrow, the interest rate, and the time period that you borrow the actual money, that will determine the amount you're going to owe in simple interest. So the rate will be stated as a percentage. The time will be stated in terms of years. Okay? For example, we have Hope Slater borrowed 40,000 for office furniture. The loan was for a 6 months at an annual interest rate of 4%. What are Hope's interest and maturity value? So again, interest equals principal times rate times time. The principal amount is 40,000. The interest rate is 4%, written as 0.04 as a decimal, and the time factor is 6/12. This 4% is the rate for an entire year. That is the annual interest rate. This loan was only outstanding for 6 months. So the time factor is 6/12, meaning the loan is outstanding for 6 months out of a 12-month time period because, again, the rate is given the annual basis. In terms of month, your denominator will always be 12. And in this case, the 6 shows the actual length of time the loan is going to be outstanding. So the interest on this loan, 40,000 times 0.04 times 6/12 would give you interest of $800. At maturity, you must pay the 40,000 borrowed plus the $800 in interest. The maturity value would be 40,000. Excuse me, $800 would be the actual maturity value. Now, if you want this time factor being 6/12 to make it easier, you can reduce it to its lowest form, which would be 1/2 or 1/2. Let's try another one. Hope borrowed 40,000. This time the loan is for 1 year at a rate of 40%. Because the loan is for 1 year, the time factor will just be 1 for one full year, or you can say 12 out of 12 months, which is also equal to 1. So if the loan was outstanding for the entire year, the interest on the loan would be $1,600. So when the loan is paid back, you're paying back the 40,000 that was borrowed plus the accrued interest of 1,600. Maturity value will be $41,600. This time the loan period is going to be 18 months. You're still borrowing 40,000 at a rate of 40%. Because again, 4% is the rate for 1 year. The denominator is going to be 12. Our numerator is going to be 18 because this loan is for 18 months. So the loan is going to be 18/12. Once again, you can reduce this to its lowest form. You can divide each of these by the number 6, and that would give you 3/2. The accrued interest on the loan would total $2,400. So when the loan matures 18 months later, the total amount paid back would equal $42,400. Okay. There are two different methods of calculating interest and maturity. One is called the exact interest. This is used by the Federal Reserve Bank and also by the federal government. With the exact interest formula, for time, we put it in terms of days. So the exact number of days of the loan divided by 365, the number of days in a year. So we got Joe, who borrowed $50,000 on March the 1st at a 5% annual interest rate. The loan becomes due on July 6th. So you're going to ask yourself, from March 4th through July 6th is going to be how many days? That equates to 124 days. So our principal, 50,000. The rate is 0.05, but for our time factor, 124 being the exact days over 365 days, the accrued interest on this loan would total $849.32. So at maturity, you must pay back the principal amount, $50,000 that was borrowed, plus the accrued interest, maturity value, $50,849.32. There's another method called the ordinary interest. We call it the banker's rule. It's used by more of the state banks or ones that are not federal-owned banks, and it's also used in academia. We use 360 days instead of 365. Why is that? Because it's easier to calculate because it's 360 compared to 365. Often it gives you more of an even number, which makes it easy to do the actual calculations. So we take Joe again, same time period, but this time with ordinary interest, you divide the 124 days by 360 to get interest amount of $861.11. So at maturity, the amount that must be paid back is $50,861.11. Now we have Don, who borrowed $15,000 on May 4th at 8% interest. Principal and interest due on August 10th. So if we're using the exact interest method, principal times rate times time, 15,000, 8% is 0.08 as a decimal. From May 4th through August 10th is 98 days, divided by 365. The accrued interest would be $322.19. So at maturity, the amount paid back would be $15,322.19. Compared to the ordinary interest days, put that up here, you would take the 98 divided by 360. So now the interest would be $326.67. So notice that if a bank is using the ordinary interest approach, you will pay more in interest than if they're using the exact days approach. So if you're borrowing money, ask the lender for the interest calculation, or are they using the exact interest approach or ordinary? You prefer the exact interest because the length of time is longer. We're doing the denominator, which means the accrued interest is going to be a smaller amount. Okay? You can thank me later. Now let's say that I'm trying to solve for one of the unknown, whether it's the principal, interest, rate, or time. We can rewrite our formula to get any unknown variable by itself to solve for the unknown variable. For example, let's go back here. Tim Jarvis paid the bank in interest $19.48 at 9.5% interest for 90 days. The question is, how much did Tim borrow using the ordinary interest method. So now we're trying to find the principal amount. I've rewritten the formula so the principal is now going to be by itself, and we're trying to solve for the unknown variable. So the interest rate, interest earned, was $19.48. Interest rate is 9.5%, which is 0.095 as a decimal. And because we're using the ordinary method, and it's 90 days, your time would be 90 divided by 360. So you got 0.095, which is your rate, times time, 90 over 360. Now again, to simplify things, the time of 90 over 360, you could put in its lowest form, which would be 1 over 4. But the interest, the principal amount, the amount that Tim would have borrowed, in this case, is $820.21 based upon the calculations. Now you can check your math. If you put in the principal amount times the rate and the time, it should give the actual amount of interest. Now I hear you saying, who's going to borrow $820.21? I know I didn't make up these numbers, but that's how you do the actual calculations. Let's try another one. This time, let's say we did not know the interest rate. We have the principal amount, we have the interest and the days, but now we're trying to figure out what's the actual rate that Tim paid for this loan. So again, you can always rewrite the formula to get any unknown variable by itself. So the interest was $19.48, principal was $820.21, time was 90 over 360. And again, you can convert this to 1 over 4 to simplify things. So this would mean that based upon these numbers, it comes out to an interest rate of 9.5%. You can always put the numbers back into the original formula to check it and to make sure that your numbers are correct. Okay, one more, but this time we're going to figure out the actual time. We know the principal amount, we know the amount of interest that we paid, and we know the rate. And we're saying now what was the length of time for this particular transaction. So time equals interest divided by principal times rate. Interest was $19.48, principal amount, and here you have the rate of 0.095. And the answer comes out to be 0.25. And we're simply using the original amount to try to get a number of days. 0.25 of 360 would give you a total of 90 days. So once again, if you know any 3 of these 4 components, you can solve for the unknown variable. Set up where whichever one is unknown is by itself. So once you've done your calculations, you'll get the actual response. Okay, so that will conclude part 1 of our chapter 10 lecture notes. Stay tuned for part 2.